Hey everyone, it's Bradley from Bradley Gore Blog. And today we're actually doing the first ever video accompanying a blog post on our blog. So we're really excited about that. So thank you so much for joining us. I've been digging into NativeScript lately and loving it. So I thought I'd do a quick post to share with you guys how to do a repeater that has some animation when you add and remove items. So the first thing that you're going to want to do to follow along is actually to just create a project. So you're going to want to navigate to some directory that you want. So mine is repeater demo, and we're just going to create one based on a NativeScript template. So we can just do tns create, and then we'll name it what we want to name it. So for my case, it was repeater demo, and then we're going to pass in this template flag. And we're going to tell it to use the TNS templates hello world TS for TypeScript. And I've actually already done this. So what we're going to do now is we're going to actually go look in my editor at the application. So when you generate the hello world template through the TNS command, what you're actually going to get is you're going to get a whole project that does kind of a button countdown type thing. So you keep clicking a button or tapping a button until you've tapped all the times that's needed to unlock a tap achievement. We're going to kind of follow suit here with just a button tap driven type of thing, except we're going to count up into a list of items. Every time you tap, we'll add an item to the list, and the list of items will drive our repeater. So the only two files that we're actually going to care about in this app are mainpage.xml and mainpage.ts. So the other files, you can leave them in there as I've done in this project, or you can remove them, whichever you prefer. If you remove them, just make sure you remove any references to the view model that is going to come by default in the main page TypeScript file. So let's get started with our view. We're just going to have a page, and we're going to have kind of some of the standard stuff that you're going to see in a TypeScript app. We're going to have an on-page load event, so you can use the loaded attribute on the page, and you can on any view element actually that NativeScript has, and you can say when this view is loaded, I want to fire this function. We're going to have a stack layout. Stack layout just throws things vertically on the screen. So if you have a button and the next thing you have a label or another button, it's just going to put them one on top of the other. You can set its orientation, but for this demo we're actually just going to use it how it is by default. Here's our button that is going to add items to the array. And if you notice here, we have a tap attribute that's just going to pass, that's going to reference a function that is going to be exported from our TypeScript file. So let's look at this repeater. This is really the crux of what I wanted to go over in this post. The repeater is a pretty powerful component that NativeScript has, and you can think of it kind of like the kid sibling to the list view. It's not as powerful in that it doesn't have all of the features like the pull to refresh or the infinite scrolling, those types of things. However, it does a good job of repeating, which is what it's supposed to do. So it repeats over the items in a list, and it will generate a view based on an item template that you give it. If you don't need those other functionalities, this is a great alternative. So I've given mine an ID, and this is simply so that later on down the line I can retrieve a reference to my repeater view if needed or when needed. And let's take a look at what we can pass this thing. So we can pass it the items that we're going to provide, and if you notice here, we're using these curly braces. So if maybe you've not looked into NativeScript yet, maybe you have looked into web frameworks that use this type of syntax. So Angular or Handlebars, Mustache, those type of things. NativeScript kind of follows the same pattern here, that you can use the double curly braces, and it tells NativeScript, hey, you're going to interpolate this with something from the data that's driving this view. And so we'll look at that in a minute in the TypeScript file, exactly how to wire this up. And then I've just got some inline styling just to be very, very quick for this demo here. Now, the repeater exposes an item template that you can manipulate. The item template is essentially what it sounds like. Every time that it sees an item in the list and it wants to render a view for that item, it is going to use the template that you give it. And this view is going to have access to that item. And what you're going to be able to do is you're going to do something like this. So in our case, the items is simply an array of numbers. So I can set the label text to $value, again using the curly braces to show the template parser that we want to pull something from our binding context, and I just want to reference it by $value. Now that's good for primitives in your array, but if you have objects, then you're going to want to reference a property name. So if we had an object of people, maybe this would say name instead of $value, because we wouldn't want to just spit out an object into the text here. It would just come out as you've probably seen other times, maybe in the console, maybe in the web, where if you don't realize something is an object or you forgot to add a property accessor in the interpolation, you might see just square brackets that say object object. And of course, that's extremely valuable information to have in your view. So we don't want to have that. So the item template is going to just be a grid layout. The grid layout is a really powerful component that NativeScript has. It allows you to declare what your columns are going to look like. So in this case, what we've done is we've said we're going to have two columns. One, we're going to use a star, and the star is a wildcard basically that just means, hey, whatever amount of space is available to this column, I want it. I want it all. Now, how does it know what's available? Well, if this were only a single column grid, then it would take up the whole screen width. Otherwise, it'll look at the other column definitions and it'll say, okay, are there any other columns that want to, take some of this space? And there is in this case. It's a second column that just uses auto. Now, auto basically tells the rendering, hey, I want to take up only the amount of space that my content needs. So if in that second column you have a little icon, like a font icon or something like that, it's going to take up only the space that that thing needs. If you have a big string of text, it may end up taking all of it. So you want to make sure to think ahead when you're designing these grid layouts and kind of plan ahead for how your columns are going to kind of chunk up, and then you can just declaratively set those things right here in the columns. You can also do the same for your rows. In this case, we're going to have two rows. They're both auto, so I only want to take up the vertical space that is necessary to display the content of each row. And then again, we just have some inline styling. So let's look at the first column here and the first row. So this label. Now notice that I specified that its column is 0. I actually didn't have to do that. The default inside of a grid layout is that the row is 0 and the column is 0. But for this case, I did. I went ahead and just put it as column 0. So it is going to take up all the space that it can possibly take up. And let's give it some text here, which is again going to be that $value syntax. And we gave it an inline style. Next, we have a button. The button is actually going to be that second column. So the button, I only need you to take up whatever you need to take up and give the rest of the space to the label. Because in a real world app, this label may be a lot more than just a number, which is the case here. It's likely going to be, maybe it's a calendar listing, an event listing, and so you're going to have some type of name and description and maybe even the location of the event. We're going to give it some text of delete, and we're also going to have a tap event. So when you tap this button, I want you to call this function, remove item. Now, an interesting thing here with NativeScript is that you don't actually have any kind of notion of like a horizontal rule or a a divider type component. So what you can use is a stack layout. So if you think of a stack layout is just like a div. If you do web development and you have ever had to use a div as kind of like the MacGyver all-purpose Swiss Army element, because we've all had to do that, then that's kind of what the stack layout's for. And so this, or what it can be for. The stack layout in this case is going to be used as an item separator, because you can't currently do just a bottom border in NativeScript. So what we maybe would do otherwise is on this grid layout, we would say, hey, give yourself a bottom border, a border width of 2, and maybe a background, maybe a border color of the light gray. But you can't do that yet. So what we're going to do is we're going to use the stack layout. We're going to tell it to take up 2 columns wide. So if you've ever worked with HTML tables where you can use the call span, this is exactly the same here, where we can say, hey, this stack layout needs to take up both columns. So it's going to stretch all the way across. And then we can set its row to 1. So because it's taking up both columns, we don't need to tell it which column it's in both. But we do need to tell it, hey, this is column number 1, because remember the default is 0. And if you remember, that second column also got an auto as far as the row width. Or that second row got an auto as far as its height. So because this has a height of 1, it's only going to take up that 1 unit. And so with NativeScript or with native, you don't really have the notion of pixels so much as like density display units or whatever they're called. It's basically, we'll just call them units for the sake of this tutorial. We're going to give this a background color of light gray, and that's going to act as our divider between our items. That way we kind of know where one item starts and another item ends very easily. And then we're back to the closing tag of our grid layout and the closing tag of our item template. So that's the template in a nutshell. So now let's look at our TypeScript file and let's see how this template gets wired up. Alright, so what I've done is I've kind of moved everything way down so you can't see it, and we're going to pull it all up a little bit at a time and just kind of see what's going on. The first thing, as with pretty much any TypeScript file, is going to be your list of references. Now, if you've worked with TypeScript before, or if you've looked into TypeScript, then you may notice some of these items, and some of these may look familiar. Maybe you've seen page being pulled in before, because that's kind of a typical one that you're going to pull in. Maybe you've seen event data and observable array, but there's a few things that we're pulling in that you may kind of be questioning, like, why are we doing that? One is repeater. Well, we've already declared that our view is going to have a repeater. We did that declaratively in the view in the XML. So why do we really need a reference to the repeater object here in our code? And same with stack layout. There's a couple very good reasons for that, and we'll actually get to that in just a second. But for now, let's just kind of talk about how this page is going to work and what we're going to be showing. So as we've mentioned, this is going to be a super simple list of items that's just going to start at 0 and display 0, 1, 2, 3, like however many times you click the button, it'll display that many items, and the number will just keep going up. So what I'm going to do is initialize a variable that's kind of going to be accessible through the whole set of functions that we're going to expose for this TypeScript file. And its type is going to be pageModule.page. We're also going to have a counter variable, and its number is it's a number type, and it's going to initialize to 0. So let's look at the page load function. So if you recall, in the page we had loaded equals on page load. And so here's the function that we're exposing, and it takes an argument that is of type event data. Event data is part of the the whole observable ecosystem that NativeScript has, and the argument is going to have an object. So the event data has an object that is the item that's raised the event. In this case, the item that raised the event is actually a view, or actually, to be more specific, it's a page. So we're actually going to use the TypeScript cast notation here to cast the args.object as a page. That way we can set it onto our thisPage variable, which we already declared before that its type was going to be page. The second thing that we're going to do is we're going to set the binding context for the page. Now the binding context in NativeScript is basically how the glue. It's basically saying, hey, anytime that you see those interpolation symbols, the double curly braces, this is the object that you need to look at. So we can set this for the entire page, and this is what we've got. Is we've got an object. We don't need the binding context here to be an observable object, so I'm just doing a plain JavaScript object. But if you notice, our items is an observable array, and I'm initializing it just to an empty array. Now, very cool thing to know about the binding context in NativeScript. Let's say that you had a page with a certain binding context, and that object was kind of complicated. It had several different properties that were also objects, that also had several properties that were also objects, and so on and so forth. And let's say that a certain piece of your UI dealt with something that was nested a few things down. In your markup, that could get kind of annoying to have to type, oh, here's a label, and it's widget dot something else dot another thing, and that's its text. So if you have a chunk of markup that is specific to a certain piece of data that's contained maybe kind of deep within that object, or heck, even from another object altogether, maybe it's just like an associative piece of data that comes from an entirely different object, but you need to show it on the same screen. What you can do is you can actually get a reference to that view specifically, and you can set its binding context to that object, and then you can just reference the properties directly. So let's say the object was a salesperson. Well, rather than doing something like weekly report dot organizations or dot organization dot whatever dot marketing dot sales person, going on down, however the object would work out, rather than doing all that mess, you can set the binding context of the object that you actually need to access, and then you can just, in those double curly braces, just say, hey, just show me the name. And so as long as you don't make it too obnoxious in your markup, so one thing that may be good to do is kind of set it to one object above. That way you could do like salesperson.name or something like that to make it kind of clear where the thing is coming from. But you can totally do that with your binding context. You can change them. It doesn't have to be the same binding context for the entire page. So that's pretty cool. So let's now look at how we can add an item to our view here. All right. So what we're going to do, the first thing that we're going to do, sorry, I noticed that I didn't really need this the way that it was, so I'm going to modify it on the fly. All right, there we go. And we're going to actually just reference the binding context for the page, and we're going to get the items. Remember, this is an observable array, but because the observable array in NativeScript mimics the API of a JavaScript array, we have methods on it like push or unshift or reduce or map, those types of things, filter, etc. So what I'm going to do is I'm just going to say, hey, whatever the current counter value is, just toString it and push it on the stack. Now you could have done this with a regular array, like the items didn't have to be an observable array. But one of the great things about the observable array is that whenever you call one of those methods that are going to change the state, like you call push or you call unshift or splice, when you call one of those things internally, it's going to say, okay, I know that these things mutate my state, so I'm going to notify anything that's subscribed to my event ecosystem, and I'm going to say, hey, I've changed. Well, it just so happens that the repeater, anytime you feed it a list of items, it's going to check to see if that list is an observable array. And if so, it's going to add an event handler to it and say, hey, observable array, whenever you change, you let me know. And then I'll refresh my listing of views and we're all good to go. If you did not use an observable array here, you would actually have to manually get a handle to your repeater and then call refresh on it to tell it, hey, I know you don't know this, but the stuff that you're going off of is old. I've made some changes. You need to reload yourself. All right, so now that we've done that, let's increment the counter so that the next time we roll through, we get the next number up. And we're just going to get a handle to the very last view in our repeater. Now, when I was first digging into the repeater, I didn't really know exactly how it all worked, and so I was having to read through the source code and stuff. And the way they've made this work is pretty slick. And so we're just going to roll with it here and kind of walk through how you can access the items in the repeater just at will, whichever item that you want. In our case, it's the last item in the list. So we're going to get the index that we would expect this view to be at, which is going to be the last item index, which is, again, we're just accessing items just like an array. Items.length -1, because arrays are 0-based indexes. If you have 6 items, that 6th item is going to have an index of 5. Now we need to get a handle to our repeater. Now we assigned an ID to the repeater called repeated items list, and we can easily get a handle to that object by just doing this page.getViewById and passing in the ID. Now we know that it's going to be a repeater because we put the ID on the repeater. So we can actually use TypeScript to cast that as a type of repeater or an instance of repeater. And now whenever we type repeater, we can get the IntelliSense to say, hey, what would you like to do with a repeater? Here's the stuff available. Well, one of the things available is items layout. Items layout is actually the container that the items are going to live in. So whereas the item template is going to be instantiated, or that template is going to be basically copied and inflated for every single item in your list, the items layout is going to be instantiated one time, and it is going to be the container in which all of your items reside, or items views reside. In the default case, as you can see from the tooltip here, it is going to be a stack layout with orientation vertical, which is the default orientation. So we did not modify our items layout, so we're going to leave, we're actually just going to cast this as stack layout, and then we can use the stack layouts API. So the stack layout has a really handy method called getChildAt, which lets you pass in an index and it'll return the view, the reference to the view that is a child at that index. This is different from other views. Other views will allow you to have a function that you want to run for each child, or other views will let you add a child or remove a child. But to get the child at a specified index, that's more difficult in other views. You would actually have to just do a probably some kind of for loop and then track it yourself which index you're at. But the stack layout has it built in that we can just get a child at, and it's actually part of the layout base. If you look at the tooltip, that when we click on the get child at, it tells us that, hey, this is actually from layout base. So stack layout extends layout base. Layout base has a get child at method, and it returns a view. Great. Well, that's what we want, is we want the handle to the view that was just added because we changed our binding context. We added an item to our list. So we have our new child view, just do a quick check just to make sure that we're not going to try to call methods and properties on this thing if it's undefined, which shouldn't happen, but best to be safe. So the first thing that we're going to do is we're going to set the scale x and the scale y both to 0. This is basically going to zoom out the item to where it has no width and no height. Now let's animate them back into 1. Now this is not the max, of course, that you can scale, but it is basically the normal, let's call it. So like if we hadn't modified the scale at all, let's bring it back to the height and the width that it would have had it been untouched. And NativeScript has excellent animation baked right into all of its views. You can just call .animate. You can pass it, part of this animation definition object, it'll take a scale, and you can just pass in your x and your y, and the duration, which is, in our case, 300. Alright, awesome. So adding an item actually has more code to it than deleting an item, believe it or not. Deleting an item took a minute to figure out, but it's actually pretty simple. Let's delete some of the space. Alright. If you remember from our XML, we had a button inside of the item template, and anytime you tap it, it was going to call this remove item. Now again, we have an event data object that's going to come in. We call it arg here, and the event data again has an object property, and in our case we know it was a button that was clicked, and so we're just going to cast it to a type of view. We don't really need to cast it as a button to go down to be that specific. All that really matters here is that it was a view, and there's a couple things on the view object that we can access. And then we're going to get the index. So what we actually need is the binding context of that view. So remember how before I said that you can actually set the binding context of individual chunks of view inside your page. So our items are just numbers. So the binding context of this view was just a number, which is why that dollar value was basically just a keyword, so to speak, that tells the NativeScript view parser that says, hey, the binding context, I just want the value of it. So it's the binding context for that view. So because each view can have its own separate binding context, what we can do is we can look in our source list of all the items, and we can, again, the NativeScript observable array mimics the API of a JavaScript array. So we can call .indexOf, we can pass it an item, and we can say, hey, what's your index of this item? And it will pass back the index. Now here is a quick little gotcha that I ran into at first. I had my access to the view, and I was going to animate it. Yay! But then what happened was the button slid off the screen, but the label stayed right there, and so did our little separator. The little one unit high light gray separator that we have. So then I realized that, okay, the view, just because it animates off, I actually need to walk all the way up to the topmost parent in the item list, or in the item template. So if we look back at our XML, we see that the button was here. So animating this button alone is not going to give you the effect that you want. You actually need to make sure that you know kind of where your element is in your view hierarchy, because you want to go all the way to the parent for that item. And so in our case, it's just up one generation. So what we'll do is we'll call tappedView.parent.animate, and again we're going to pass in an animation definition object. And in this case, we're not going to use scale because we did that when we were adding a new item. Let's go ahead and use translate. Translate will basically just manipulate the origin X and the origin Y, or the translate X, the translate X and the translate Y properties of the view. So we're going to make the X be negative 500 and the Y, we don't want to modify the Y, so we'll leave it at 0. And that's basically just going to make the whole element slide left off the screen. Give it a duration of 300, and then promises are awesome, and animations are awesome, and mixing the two together is awesome, like squared. So NativeScript has these sweet animations right out of the box that give promises back as a result. So we can just say animate this thing. When that's done, then run this function. Now the function that we want to run is actually that we just want to actually remove the item from our source. If you remember here, all that we actually did was we got the index of the item that we want to remove, and then we animated that item's view, the entire view for the item. We did not actually change our observable array yet. So we need to handle that now. So now that it's done navigating off the screen, we're going to be able to get the binding context.items, and then again, the observable array mimics the JavaScript array. We'll call .splice, pass it our index, and pass it a length of 1. So basically we're telling it, hey, start at this index and take one item away, which is going to be the item that was deleted. And now that that's done, we can take a look at a demo. Here we go. And I've already got this running, and we're just going to click the button a few times to add an item. Alright, and you see how it just kind of zooms in, and the number just keeps increasing by 1 every time. And now let's delete a few of those. So I'm going to delete item number 1, and you're going to see it slide left off the screen, and then you'll see the gap close up where the items 2 through 5 move upward to meet item 0. So we'll delete that. Alright. And we can just keep going. Now one thing to note here is that we're using a repeater and we're not using any kind of scroll view. So if I keep clicking to add items, I can't access any of those items. I can't scroll. So what I would have to do is delete a bunch of them, like I'm doing now, to finally get to see the end of the list. So that's one thing that you want to keep in mind. Depending on your use case, you may have a scenario where a repeater is a good fit because you don't need all the extra functionality of the list view, but you want to be cognizant that the repeater is just going to keep taking up space, but it's not going to actually scroll anywhere unless you have a scroll view around it. So that's all I've got for you in this post. Please stay tuned for future posts because we're going to be looking at doing some more fancy stuff with a repeater to where that you can add 2 layers for each view, for each item's view. One as kind of a background layer that maybe has a button on the left and a button on the right. One that's more of a foreground layer where you can slide it to the left or to the right to show one of those buttons from the background. And that should be a lot of fun, so be looking for that probably in the next 4 weeks. Until then, this is Bradley from Bradley Gore Blog. Thank you so much for joining.